Python big_o seems to return completely incorrect results. What am I doing wrong? I am comparing runtimes of different ways of flattening a list of lists using the big_o module, and for following methods my function does not return the expected results, namely this one. Returns constant, which can't possibly be true. This one. Returns cubic, shouldn't it be quadratic at most? While this one returns linear, I'm quite sure it should be quadratic, see proof here. Furthermore, the list comprehension 1 returns polynomial, which seems terrifying, would expect linear here as well. Code used to calculate the complexities. Output. What is it that I'm doing, or understanding, wrong? Many thanks in advance for useful tips.
Your lambda ignores its argument n and instead always produce the same constant size input. Produce input of size n instead. A note, originally the question had 8 functions and 7 of them were judged constant time. It was edited to a larger constant and then got other judgments. I guess your computer's speed is somewhat unstable, as the constant input should still lead to constant runtimes and thus constant time judgments. In any case, the input generating function should be fixed like I said. Given that it's two-dimensional, you could for example produce n lists of size 1, 1 list of size n, or sqrt n lists of size sqrt n. Presumably n lists of size 1 is what you want if your goal is to demonstrate that some r is bad. For example, a full program. Sample results. You can see it gets it right most of the time, but still sometimes thinks logarithmic instead of linear. On a more stable system it might work better. Larger max_n values should help, too. But I tried and then big_o crashed with some known internal error. Also note that I use different max_n values for the different functions. It's no good to use the same for all. If you use the same for all, then if it's large, a quadratic time solution takes unbearably long, and if it's small, a linear time solution takes so little time that big_o has trouble differentiating it from logarithmic or linearithmic. There doesn't seem to be a medium value that's good for all. Ideally, big_o would automatically adjust max_n appropriately, but I don't think it supports that.
First, it's important to understand that big O notation is about estimating the asymptotic growth of functions, i.e. how they behave when input size grows to infinity. For example, if an algorithm is said to run in O(n²), it means, roughly, that when the input size, n, grows to infinity, the execution time will be bound by a constant multiplied by n². For a more accurate definition, see the link above. Therefore, the real bigo has nothing to do with concrete time measurements, in particular because we cannot measure infinite input, at least in the theoretical sense. Libraries like Pippy/bigo try to estimate how the processing time grows when input size grows. But it is only an estimation and depends heavily on the properties of the time function and size of input you actually give it. In your case, it seems like you gave it too small input. This resulted in very short execution times that caused the estimation method to fail. You can try to increase the input size significantly. Update: the last paragraph, regarding the reason the input is too small, was a guess that turned out to be wrong. See a Kelly Bundy's answer above.
I fjor väntas en månad börja sätta en hyres och trading.